This video will provide a very short and very simple introduction into what different possibilities users have when they're using HPC clusters to store and keep their files and data. So if you're using a HPC clusters, users will log into this via a login node. And so we've got the login node here. And this is how users will access the cluster and its facilities. As the login node or login nodes, sometimes there's more than one, are just standard computer nodes. The HPC clusters and facilities will, in most cases, give users a different file system to store and keep their data. And these are file systems that are shared out from a different location, from different computers. And so this is why we call them shared file systems. I'll draw the box around this. Apart from the login nodes and then the hardware for that houses the shared file systems, every HPC clusters will have compute nodes. Again, there are single nodes, but a lot of them. But each of these nodes might have a file system or space for users to store or keep their data or put their data for a short amount of time. So we've got the compute nodes. Compute nodes. So we have the login node, the shared file system, and the compute nodes. And most HPC centers will also have an availability of a space to actually store data. And with storage, I mean proper storage that is backed up and that is reasonably permanent or for a very long time, where every user can basically put their data and know it's going to be kept there in a very safe way for quite a long time. And so we've got storage. And so these are the main systems or locations where users could store or keep their files and data. And I'm now going to go through some of the different ones that you might already know about and that could be available. So one of the most common ones when you log into the clusters, most users will basically land in their home directory. Now, as I said before, the login node is usually just a small node. It doesn't have a lot of space. So if you have a lot of users, you need somewhere else to house the home directory for all of these. And so they are commonly housed on a shared file system. So I'm going to put home into the box of the file system. And so that home file system is then shared out to the login node, so users can see the home file system when they are on the login node. And so that's why I'm going to put it below here. So users logging into the login node onto the cluster will see the home directories, which is shared out from the shared file system. The shared file system will also share out this home directory to the compute nodes. And so when users are running calculations on the compute nodes also see the home directory there. Another file system that is also shared out is called Scratch. And that is actually a very common naming convention on most, and I misspelled that. So that is Scratch. And again, that is shared out to the login node. And also the compute nodes. And so there's the major differences between the home and the Scratch file system. Home, in most cases, is relatively small. It is often only a few gigabytes. Some of the national facilities only have 5 or 10 gigabytes in home available to users. And so users are encouraged to keep like small input files, scripts, compiled software, installed software environments in a home directory because they're in most cases not very large. And also the home directory or the home file system has the advantage that there's usually no time limits on it. So while it is small, files that are older than a certain amount of time are not deleted. That's a very uncommon thing to do. A lot of HPC centers also do snapshots or backups of the home file system. Not all do, so that's something that users need to investigate and check at the start. The Scratch file system provides users to keep larger amounts of files and data. So the quota that is available to them is much, much larger than home. In some cluster facilities, Scratch can be very large or unlimited. However, there'll be a very strict time limit on files. If it's unlimited, the strict file limit could be that only a week or only during calculations. So there's usually limitations and restrictions on Scratch, either in larger quotas on disk space, the number of files you're allowed to have in there, so the inode quotas, and then in most cases there'll be a limit on how old your files or data is allowed to be, so you can't keep files in there for a long time. In a lot of cases the time is a month or 3 months or something like that. Different HPC systems might have a tiered system for Scratch, so there could be a Scratch 1, a Scratch 2, a Scratch 3, for example, and these might differ in performance. So the more data you can have in it, or the longer you can have your data sitting in there, the slower the performance might be. So, and then if it's a high performance file system, but very fast read and write access that you can use for your calculations, then you might not be allowed to leave data there for a long time. So again, different HPC centers differ very significantly on how they provide this type of space to their users. And in a lot of cases, there's different possibilities, so it's worthwhile investigating what's available. Now, so we've done the shared file systems, which are home and Scratch and other ones as well, depending on the HPC cluster you're using. But we also have the compute nodes. And so on the compute nodes, you have, let's call it local Scratch. So this will be called something different on most clusters, but what this local Scratch basically is, it is the local disk on each of the nodes. Now you notice that I haven't put that one anywhere else basically, and that is because the local Scratch from the compute nodes is not shared anywhere. So it's not a shared file system, it's a local file system that is only local to one particular node. And with that, it's in most cases are usually only available during a calculation, so users will have no access to that outside of a calculation. So this has an advantage. One is that it behaves just similar to a disk that sits in your desktop or laptop, And that is that it has a certain size, so there's a limit on how much files or how much data you can put there. But it doesn't have the limitations on number of files, for example. It doesn't have the typical inode quotas that you get on shared file systems. So if your calculation's writing out a lot of files, using the local disk on the compute node is in most cases the best option for those kind of calculations. It also gets you around quotas. So if you write out a lot of files during the calculations that you can then either zip up or bundle up or delete even because they're not needed once the calculation is finished, local scratch does not count to your quotas in home and the shared file systems. So using local scratch during a calculation usually has no impact on your quotas unless you then copy all the files back to your shared file systems. There's one last file system that we're going to talk about, and that is storage. So I'm going to call that storage. And so in some cases, in some HPC facilities, not all of them, the storage file system is exposed or shared out to the login node. So I'm going to put that here. But that's not always the case. A lot of HPC centers will actually put a data mover in between the login nodes and the storage that will allow users to move data from when they're on the login node to the storage, basically. If it is directly shared out to the login node, then users can just copy data into the storage file system from the login nodes. The majority of HPC centers will not make the storage space available on the compute nodes. It's rather rare. Some do, which is why I put the dotted line there to the compute nodes. And because there's some limitations on how the storage file system can be used. Most storage file systems are backed up or attached to a tape file system. And that means that the storage file system is much slower in performance than all the other shared file systems that are available. So directly writing out to a storage file system is a very bad idea because it will slow down the calculations significantly. It does not have the performance that people want to have during a calculation. Also, if it's put together, the storage is with a backup system, then computing directly during a calculation to the storage file system is a bad idea because it really messes up with the backup at the back end. You really don't want to have to. A fast changing file system is no good for doing backups, and so you should never use that during your calculations. A way that these storage file systems can be used during calculations is that if they're available on the compute nodes, users can copy large input files or read in large input files at the start of their calculation, which is if you're reading in a large chunk or a large bit, it's just the same as if you would have to copy it over in one go and then use it. Or you can basically copy output right after the calculation is finished back to your storage file system. And so these are ways that you can use the storage file system, but it should never be used directly, putting output directly into it during a calculation. Before and after is possible, but not during a calculation. So these are the file systems that are available to users in most HPC systems. And users should really, when they start using a HPC system, really should take some time and effort to investigate what different file systems are available, what are the limitations on storing their data in different file systems in terms of disk space, number of files, limitations on how long files and data can be kept for, so time limitations, where the different file systems are available, like on the compute nodes, is the storage directly available or not, things like this, and then plan their workflows around their data and how data is used in their calculations. So users should really be aware of what happens with data during their calculations. So do they need to read in a large input file, so input data? Does that data have to be available during the calculations? Are the calculations writing out a lot of files, a lot of small files, or a lot of large files, or just one large file, for example? Do these files that are written out during the calculations, do they need to be kept after the calculation, or can they be discarded after the calculation? And things like this. So users really have to be aware of how data is used during their calculations and before and after as well, and then make a very informed choice on their workflows with the data in their calculations.